Hey guys, so we got one final topic before the test, but one final topic left in this sort of basic intro to object-oriented programming, and that is the use of the keyword static. So static variables, static methods, and static constants. We've already seen this keyword. If we take a look at the screen here, I'm looking at the Circle 6 class here, which is the last version of the circle. If we go over into Circle 6 test, we've seen it in the main method. So this is a graphical application. So the main method is down here, and we don't normally touch it. We use the start method, but the signature is the same. So we now know what public means. We now know what the void part means. We know that this is a method called main that doesn't return anything. We know that it's a public method, meaning it can be called from anywhere outside of the class. This is the last sort of piece of the puzzle. Well, we still have the square brackets to deal with, but beyond that, just on the signature of it, this is the last piece of the puzzle, the word static here. Let me do it by way of example. Let's say you have, if we go to our bank account class, we might want to, right now we have the application programmer is entering an ID. But bank account IDs are supposed to be unique. So we might want to find some way of generating a unique ID for each new bank account. Now, one way to do that would be to keep track of how many accounts we've created. So let's say we've created 1,000 accounts so far. And then assigning IDs based on that. So maybe the last account had an ID of 1,000. So the next one that gets created from anywhere in the system should have the ID of 1001, 1001. And then the one after that should be 1002, and so on. So to make that happen, what we need is, or what would be handy, would be a variable that exists somewhere in the system that's not attached to any particular bank account, that's tracking the number of accounts. Similarly, we might want to do the same thing with circles. So this is a variable. Let's say we want a variable that counts the number of circles that have been created. So we want to know, and they might have been created from a lot of different places. There might be a lot of different parts of the code where we are creating circles, and we want to keep track of how many we've currently got in the system, how many have been created. So this is a variable that's not really appropriate for this to be an instance variable. So instance variables are attached to an object. So like radius here is an instance variable. It doesn't exist until I create a Circle 6 object, and then I get one radius variable for every Circle 6 object or instance, for every instance of that class. What we want here is a variable that there's only one copy of it, and it would be nice to attach it to Circle 6. But we want there to be only one copy. So the way you do that is I can create a private variable here, and I'll make it static, and it'll be an int, and we'll call it num circles. Okay, so this is a different kind of variable. The keyword static makes a big difference here. This variable will not be created when a Circle 6 object is created. It is not an instance variable. It's static, which means that there's only ever one copy of num circles. All Circle 6 objects will have access to it. It's private, so only from within the class. But no matter which Circle 6 object is accessing it, they're all accessing the same variable. If you like, one way to think of it is that it's a variable that's attached to the class. It's not attached to the instance, it's attached to the class itself. So the class is also a thing. I sometimes think of these things as, think of RAM as a big sheet of cookie dough, and the class is the cookie cutter. You can use the class to stamp out a bunch of cookies, but you can also attach things to the cookie cutter itself. So you could put a notch on the cookie cutter to every time you stamp out a cookie, put a notch on it. So the class itself can contain variables and methods actually, and can track things. So if I got this variable, this private static variable called num circles, what I want to do is every time a circle is created, so you can see we have a bunch of constructors. They're all folded up by IntelliJ, but they're all calling the same. This is the main constructor. The others all call this one. So what I'll do here is I will just say num circles plus equals 1. Notice the italics. So the italics indicate that this is not an instance variable, but that I'm accessing a class variable here. I should probably initialize it to be 0. So this variable will be created at compile time, one copy of num circles, and it will be set to 0. And then anytime I refer to num circles in here, no matter how many objects I've created, if I got 1,000 different circle 6 objects and they're all doing something with num circles, they'll all be doing it to the same num circles variable. So there's only one copy of it. Now if I want to be able to get it, I could make it public, or I could attach a getter to it. So I can go public. Now this is going to be static as well. So this is going to be a static method, int get num circles. Like that, return num circles. So now I've added a static method. So this method also doesn't attach to an object, it attaches to the circle 6 class. And I cannot, inside of a static method, I can't refer to an instance variable because it's not attached to an instance. See, this is an error. Non-static field radius cannot be referenced from a static context. So the compiler can see, oh yeah, I think you mean this radius variable here, but this is an instance variable and you are in a static method here. So this method can be called before any objects have been created. And if no objects have been created, then there are no radiuses out there. If there are objects created, let's say there are 10 objects created, again, this attaches to the class. So if I say return radius, it won't know which radius I'm talking about. So inside of a static method, you can only refer to static variables. Now inside of an instance method, like this constructor, which is basically an instance method, you can refer to static variables, but not the other way around. So now in circle 6 here, I seem to have an error. Do I still have an error? Yeah. Oh well, I'll deal with that in a second. I'm not sure where that error is coming from. It might be just IntelliJ glitching here. I'm going to go over in a circle 6 test, and you can see in this test file I'm creating 4 different circles. So let's do a system out print line here of I want to find out how many circles are in the system right now. I haven't created any objects yet. I want to access a static method, so I do it through the class, and you can see it's giving me some options there. So I'm going to print out the number of circles going from the circle 6 class. So just the name of the class dot get num circles. Notice it's in italics again, indicating that it is static. So it should be 0 when we start, and after we're done it should be set to 4 because it's returning num circles. Okay, things seem to have resolved themselves. So I'm going to go Control-Shift F10 to run it. There we go. So I've got 4 circles being printed, and you can see my results, 0 and then 4. If this had been a public variable, I would have been able to access it directly. But since it's a private one, I don't want people. I want control over it to remain within the circle 6 class. I don't want someone else to come along and assign a random number to num circles, because otherwise it won't be doing what I want, which is tracking the number of circles that have been created. Okay. So that's one use of static constants. You can use them to create variables that are, typically you use them to create variables that are either relevant to more than one object of the class or are not relevant to any objects of the class. And same thing with the methods. You create a static method when the thing that you're trying to do pertains to more than one object or pertains to no particular object. So utility methods and stuff like that are going to be static. Okay, I want to do one other thing, which is I want to show you another common use of static variables is to create constants. So I go public static final. Let's say that there's a top limit on how big my circles can be. Max circle, or max radius, let's call it. So I'm going to say that circles can't be any bigger than, oops, I need to type, than a radius of 50. So here I'm pulling out all my keywords here. This is a public variable, which means anybody can access it. It's static though, which is why it's in italics here. Static means that it attaches to circle 6, the class, and not to any object. There's only one copy of max radius. It's not an instance variable. It's final, meaning nobody can change it, which is why it's safe to make it public, and it's an int. And that's, or maybe it should be a double actually. Since radius can be a double value, I should make it a double. And then I can use it down here. I can say, let's see, when it comes to radius, I can throw an error here or something like that, or I could just do something like this. If radius is greater than max radius, this dot radius equal max radius. So our circles are going to max out. I should probably really signal an error to the user here, but this is easier. So I'm just not going to allow radiuses higher than max radius. Again, note the italics. I think do we have a set radius? Get radius? Yes, we do. So let's put that in here. Here we go. So I'm also maxing it out. So I'm giving an error if the radius is less than 0, but if the radius is bigger than the maximum, I'm just going to cap it at 50. Okay, so let's check that this works. So over in Circle 6 test, I think I am creating, yeah, see I have a radius of 50 here, and I have a radius of 123 here. What's my default radius actually? Let me just check that. My default radius is 10. Okay, so one of these circles is going to be different. Oops. When I run it this time, the final circle, which is the biggest one, is going to have a smaller radius than it did before. Stop and rerun. There we go. So we used to have a big circle here. Now this one's been capped out at a radius of 50. Okay, so there I'm making use of a system constant. Of a constant that that I want people outside to be able to see. I know it's safe to let them see it directly because they can't change it. So if I go circle 6 dot, you see now I can print out the maximum radius. Let's say max radius is like that, and I can print it out. So if I rerun this, you should see a 50.0 come out here. There you go. So static stuff is it doesn't attach to any particular object. So you use it to track stuff that is relevant to a number of different objects, or potentially to keep track of things that are not part of any particular object. Just some examples of that. The math class, which we've already used, now you can see, for example, math.py. Notice the italics. Every time we access the math class, whether it's to access a constant like pi that's in there, or whether it's to do, like, for example, math.random. See italics again? This stuff is all static. So the math class, you don't really create any instances of it. You just, it's just a holding place, kind of a repository for a bunch of utility methods to do various things with math. So that's a classic example there of a class that's just full of static stuff. The random method doesn't make sense to attach it to any particular object. What else do we know? Thread.sleep is another one. Again, this is a static method. It doesn't pertain to any particular object. Like that. See, it's italicized. Another place that we've seen this, we've seen static constants as well in a couple of places. So if I go c.setFill color dot, these things here are all static constants. So black is a color constant. The web method, Alt-Shift-Enter. There we go. So that's what I was trying to show you. It's gc.setFill, sorry. I was trying to show you this, that the web method here is also a static method. Okay, so again, you can create color objects in this case, but there are a bunch of static methods. These are referred to as factory methods for creating a color object, and they're static. Okay, let's take a look at the handout here. So there's a little rundown here of static versus instance. So instance variables are created when an object is created. There can be 0 or more of them in the system at any one time. Static variables are created at compile time. There's only ever one of them, exactly one of them in the system. So one copy in total, one copy per object. If they're public, you can actually access them through an object name, but generally speaking, you should access static stuff through the class name. It just makes it clearer what you're doing. And instance variables, if they're public, can be accessed only through the object name. They're accessible in instance methods. Static variables can be accessed in both static and in instance methods. But you cannot access an instance variable in a static method. Static methods, again, similar. They're attached to a class and they can access instance variables. Static variables, but they cannot access instance variables. Instance methods are attached to an object, so you have to create an object before you can access them. And then, use instance most of the time. So circle radius, account balance, string length. Here's some examples we've seen. The next int for a scanner, fill oval on a particular graphics context, and so on. If the variable or method pertains to one object, then it should be an instance variable or a method. If it's static variables, doesn't belong to any one object or pertains to more than one object. So number of circles, the interest rate in a bank account, for example, might apply to all bank accounts, might be globally set, so that might be a global variable, meaning that it should be an a static variable. And in math, there's a bunch of examples, thread.sleep, color.rbg, color.web, and so on. Also arctype contains constants, and so on. Okay. In a UML diagram, you access static stuff, you demonstrate static things by using underlining. So any underlined element, so here's an example. This is a proposed development of the account class. So it's got two constants in here. See, they're public constants. You can tell they're constants because they're uppercase. These are little flags to say whether an account is a checking account or a savings account. It also has a next ID. That should be private. The next ID should be private. So you use that to assign an ID to the class. So it could start at 1,000, and then every time you create an account, you add one and make the ID of that account equal to the next ID. So basically, you're numbering the accounts and you're giving each account a unique number. And we also have an annual interest rate, which is a double and has a getter method that goes with it like that. So the next ID here should definitely be private. Okay, this is a sort of a modification of the account class with some static stuff added that makes sense. If you're using Umlet, let me start up Umlet here because these are all made in Umlet. Here we go. You can see, by the way, this first class here, when you drag in this element onto the screen, it's automatically kind of showing you how to do different things. So you can see there is an underlined attribute here. It's just a class name here, and it's done with underscores. So this makes it. This is what makes it an underlined thing. So you would do something like this, minus num circles, double, and then underlining, that's an underscore again on the other side of it to make it underlined. And you could do the same thing with a method. So you have a public method, underscore public method, get num circles, int. Num circles should be an int, not a double. There we go. Okay, so that's how you do it in Umlet. So anytime you see anything underlined, it is static. Okay, so coming back to the main method is always static. And if you think about it, it makes sense. If you want to pause and just think about why is the main method static, the main method is, of course, what starts and controls the entire app. So the main method has to run before any objects are created. If it was an instance method, you would need to create an object first. And how would you create that object without a main method? So the main method has to be static. The start method of an FX application, though, is not static. So I already kind of showed you there is a static main method that calls another static method called launch. If we go back and take a look here, if you're interested in the architecture of these things, see that launch is italicized, so it's calling a static method. That method somewhere else in the system creates the object for the Java FX and then calls its start method, because this is not static. Okay, we'll get more into the architecture of that later on. Okay, and generally speaking, you should access static stuff through the class name, not through the instance name. Okay, so if you want to get the annual interest rate after creating an account, you can actually do this but you should do it this way just because it makes it clearer to everybody who's looking at your code that you are accessing a static method here. And I've got here some partial class diagrams for classes that we've used. And you can see, so now I can do one for the math diagram, so for the math class, sorry, and you can see I've underlined everything here to show that it's static. So the math class contains a bunch of static stuff. Here's graphics context, here's string and scanner, and so on. Normally we have closed book tests, so what I do is I make pictures like this available on the closed book tests, but you guys don't need it so much because your tests are going to be open book. Okay, let's take a look at the exercises for this week. So it's over here. So the only exercise here, well, so there are these dating profile exercises that have been running through the whole thing. I think we are going to look at those in class, but if you want to, if you've been following them and doing them yourself, you can, it says to add some static constants to it. This is this exact same UML diagram that I just showed you. What I would like you to do is try to do some work to update the account class to match this diagram, and then test everything to make sure that it works. So the idea is we now have two different types, checking and savings. You could define checking to be 1 and savings to be 2. When the user creates an account, they have to give it a type, and they can give it a balance if they want. The ID is now assigned automatically using next ID, which really should be private. So it's set to, maybe when you start it's set to 1,000, so the first account gets ID of 1,000, the next account gets ID of 1,001, and so on and so on. So they get unique IDs automatically assigned to them. And the annual interest rate is going to be common across all accounts now. It's going to be 0.5 or whatever. And it's a private static variable that you define inside account and you can access through a get annual interest rate. Okay, so just want you to play around with static stuff, and I will see you in class and we'll review this stuff and bring any questions that you have. There is an assignment, of course, for this week that makes use of constructors and association and a limited use of static things. I'm not going to do a video for it this time, so take a look at it. What you have to do is you have to implement a UML diagram that includes static, constructors, and association. So bring any questions, make sure you've read over that, and bring any questions you have to the live class as well, and we'll take it up there. Okay, all right, I'll see you in the live class.